multiplication of vectors. The dot product, we have two cases. The first one is the projection of vector B onto the direction of vector A. So vector A multiply vector B equal to vector A multiply component of vector B parallel to vector A. The second one is the projection of vector A onto the direction of vector B. So vector A multiply vector B equal to vector B multiply component of vector A parallel to vector B. The definition is if vector A equal to A1, A2, A3 and vector B equal to B1, B2, B3, then the dot product of vector A and vector B is given by vector A multiply vector B equal to A1, B1 plus A2, B2 plus A3, B3. The theorem of dot product is if theta is the angle between the vectors A and vector B, then vector A multiply vector B equal to magnitude vector A multiply magnitude vector B multiply cos theta. So here we have three types of angle. The first one is if we get vector A multiply vector B greater than 0, so we get acute angle. If vector A multiply vector B less than 0, we get obtuse angle. And the last one, vector A multiply vector B equal to 0, we get right angle. Example 1, find vector A multiply vector B if vector A equal to 4, 5, 1, vector B equal to 7, 5, negative 1. Vector A multiply vector B equal to 4 multiply 7 plus 5 multiply 5 and 1 multiply negative 1. The answer is 52. Example 2, vector A equal to 4i plus j minus 2k. Vector B equal to 5j minus 7k. So vector A multiply vector B equal to 4 multiply 0 plus 1 multiply 5 plus negative 2 multiply negative 7. Then the answer is 19. Example 3. Find the angle between the vectors below. Vector A equal to 4 to negative 5. Vector B equal to negative 3, 7, 2. Vector A multiply vector B equal to 4 multiply negative 3 plus 2 multiply 7 plus negative 5 multiply 2 equal to negative 8. Magnitude vector A equal to square root 4 square plus 2 square plus negative 5 square equal to square root 45. Magnitude vector B equal to square root negative 3 square plus 7 square plus 2 square equal to square root 62. To find the angle, theta equal to cos negative 1 multiply vector A multiply vector B over magnitude vector A multiply magnitude vector B. So cos negative 1 multiply negative 8 over square root 45 multiply square root 62, and the answer we get 98.71 degree. Example 4. A force is given by a vector F equal to 8i plus j plus 3k and move a particle from the point vector M 312 to the point vector N 752. Find the work done. Vector D equal to vector Mn equal to vector N minus vector M. So 752 minus 321 equal to 431. Then vector W equal to vector F multiply vector D equal to 813 multiply 431. So 8 multiply 4 plus 1 multiply 3 plus 3 multiply 1, and we get the answer 38.
Next, for the projection, you will get a two vector, which is vector A and vector B. If the question asks you the projection of B onto A, you need to use the formula that says projection of B onto A equal to A dot B over magnitude of A square times A. And if the question asks you the projection of A onto B, you need to use the formula that says projection of A onto B equal to A dot B over magnitude of B square times B. For the cross product will also be called as vector product. For the definition is if A equal to A1, A2 and A3 and B equal to B1, B2 and B3, then the cross product of A and B is the vector of C equal to A times B equal to A2 times B3 minus A3 times B2, A3 times B1 minus A1 times B3, and A1 times B2 minus A2 times B1. For the theorem, the vector A times B is orthogonal to both A and B. If theta is the angle between A and B, then magnitude of A times B equal to magnitude of A times magnitude of B times sine theta. For corollary, two non-zero vectors A and B are parallel if and only if A times B equal to 0. And lastly, the length of the cross product A times B is equal to the area of the parallelogram determined by A and B, which is area equal to magnitude of A times B. So, for the first example, if the question asks you find A times B or find the cross product of the following vector, A equal to 8, 4 and 6, B equal to 9, -2 and -4, we just need to make sure that we substitute the vector into the formula that we given in the previous slide. So after we calculate all the vector, we're gonna get the answer as -4i plus 86j minus 52k. But we need to remember that the final answer that we accepted must be in a vector. So the final answer is -4, 86 and -52. For the second example, if the question asks you, find a vector perpendicular to the plane that passes through the point A, 3, 2 and -5, and point B, 2, -6 and 4, and point C, -2, 5 and -1. First, find the point A pass through the point B, and you will get as -1, -8 and 9. Next, find point A pass through point C. The answer you will get as -5, 3 and 4. Next, you need to multiply AB and AC. So just substitute the vector you get into the formula that we used from the previous example. The final answer that you get is -59i minus 41j minus 43k. Also, for the same question, we ask you the area of triangle. For the area of triangle, you need to find the area of parallelogram first, which is magnitude of AB times AC, and you will get as square root of 7011. So for the area of triangle, just multiply 1/2 with area of parallelogram, and you will get as 41.8. For the last example, the question asks you find the area of the parallelogram with the edges V equal to I plus 5k and W equal to 2I plus 4j minus 6k. So first, you need to find the cross product between V and W by using the previous formula. So the answer you will get as negative 20i plus 16j plus 4k. Lastly, you need to find the area of the parallelogram by magnitude the cross product between V and W. So the final answer you will get is square root of 672.
Next, the triple product is the product vector A multiply vector B multiply vector C is called the scalar triple product of the vectors A, vector B, and vector C. If vector A equal to A1, A2, A3, vector B equal to B1, B2, B3, and vector C equal to C1, C2, C3, then vector A multiply vector B multiply vector C equal to A1, A2, A3, B1, B2, B3, and C1, C2, C3. Then A1, B2, B3, C2, C3 minus A2, B1, B3, C1, C3 plus A3, B1, B2, C1, C2. Then A1 multiply B2, C2 minus B3, C2 minus A2 multiply B1, C3 minus B3, C1 plus A3 multiply B1, C2 minus B2, C1. Use scalar triple product to show that the vectors A equal to 5, negative 1, 1, vector 2 equal to negative 2, 0, 4, and vector C equal to 3, 4, 5. The formula is vector A multiply vector B multiply vector C equal to 5, negative 1, 1, negative 2, 0, 4, 3, 4, 5. So 5, 0 multiply 5 minus 4 multiply 4 minus negative 1, negative 2 multiply 5 minus 4 multiply 3 plus 1, negative 2 multiply 4 minus 0 multiply 3. Then 5 multiply negative 16 minus negative 1 multiply negative 22 plus 1 multiply negative 8. Then negative 80 minus 22 minus 8, and the last answer is negative 110.
Volume of the parallelepiped. The volume of the parallelepiped determined by the vector of A, B, and C is the magnitude of their scalar triple product. So here, volume as a V equal to magnitude of A dot product with the cross product of B and C. Example for volume of the parallelepiped. The question will ask you, use scalar triple product to show that the vector of A, 1, 4, and negative 7, vector B, negative 2, negative 5, and 1, and vector C, 2, 1, negative 3. So just substitute the vector into the formula that we given before. The final answer you will get is negative 58. Since the volume of parallel pipe determined by the vector A, B, and C is negative 58, therefore A, B, C are not coplanar. Why? Because the volume of parallel pipe is negative 58, not equal to 0.